You can add a tool center point, or TCP, to a robot, but it must be as a frame that is the child of an object that is mated directly or indirectly to the robot. In this example, we'll add two different grippers to a robot, which will be used interchangeably. Each gripper will have its own TCP. In the real-world work cell, the robot will have a tool changer. In the virtual world of RapidPlan Create, we will change which gripper is to be used by defining different robot states. We'll add a mate for the first pneumatic gripper. As you may know, a mate is made up of a parent frame, a child frame, and offset values. Click on the mate button in the toolbar. Select the center point of the gripper, which will make it the child in the parent-child relationship. Then select the robot's default TCP as the parent. We'll name this mate pneumatic gripper and create two states for it, active and suppressed. To do this, change the default name, state 1, to active, and then, to also give the mate a suppressed state, click on the Enable Suppress State checkbox. When done, click OK. We will now add a frame that will become the TCP for the pneumatic gripper. We're going to place this TCP frame in the middle of the four section cups and level with them. To do this, we use the Measure tool and find the height from the bolt in the center of the gripper and copy that value by clicking on the clipboard. Control-C will also work to copy. We add a new frame using the gripper as the parent and paste in the copied height value. Because the gripper is the parent to the new TCP frame, when the pneumatic gripper is suppressed, its TCP frame will be suppressed as well. That way the scene won't get cluttered with multiple TCP frames. We name the frame Pneumatic TCP and click OK. So if we suppress the pneumatic gripper mate by right-clicking on that mate in the property tree and changing active state to suppressed state, the gripper disappears, as well as its children, in this case, its TCP. We will now mate the second parallel gripper to the robot's default TCP. Click on the Mate button, select the center point of the gripper as the child, and then select the default TCP, in this case we do it on the property tree, as the parent. Name the state active, enable the suppressed state, and name the mate parallel gripper. Click OK. We measure to find the midpoint between the gripper's fingers and add a frame there. Then it's a good practice to make sure the new TCP frame is aligned with the default TCP frame. That will make the teach pendant values for the real-world robot correspond to the values that RapidPlan Create reads out. In this example, we make the alignment using the Rotate button. We name the frame Parallel Gripper TCP. We now have a parallel gripper with a frame and a pneumatic gripper with a frame, although neither frame is a TCP yet. To do that, we use Robot Presets. Click on the Preset button in the toolbar. We'll name this preset Pneumatic Gripper. The TCP for this preset dropdown now lists the frames whose parent, either directly or indirectly, is the robot. We added this frame Pneumatic TCP to an object, the gripper, and the gripper's parent is the robot, so this frame is a valid TCP. For this preset, the pneumatic gripper is active and the parallel gripper is suppressed. We click on the plus button to create a new preset, name it Parallel Gripper, select Parallel Gripper TCP, then suppress the pneumatic gripper while making the parallel gripper active, and click OK. When we select the robot and open its jog dialog, you can see the two presets, Pneumatic Gripper and Parallel Gripper. You can switch between presets, and the TCPs and the white ball change accordingly. And if you choose to add a frame, it's added to the correct TCP.